Okay, in this video, we're going to talk about page 32 of math analysis, and it's actually the first page of notes 4, and we're going to be talking about an introduction to reference angles. What are reference angles? How do they help us? What can we do with them? So that's what we're looking at. In this first problem that we're going to do, really inconveniently, all of the angles are given in degrees, which is like, why would anyone do that? So what we want to do is we want to look at these graphs and identify which is which. And so let's take a second and do that. So this first one here, if we go counterclockwise, end up there, that's definitely 5 pi over 3 or 300 degrees. All right, so we start with that. And then the next one here is definitely 7 pi over 6, or in degrees, it's 210 degrees. And to get there, we would have rotated like this. All right, this next one is 7 pi over 4, or 315 degrees. It's actually easier to do these in radians at this point, hopefully, because we've been doing that a lot, right? So we're just going through and identifying. This should be 3 pi over 4, or 135 degrees. So I know them in degrees, but I never think of them in degrees. Mostly I think of them in radians and then convert it back. There's 2 pi over 3, or 120 degrees. Get there by doing this. This one is, okay, so it's 4 pi over 3. For some reason, I find like the pi over 3s and the pi over 4s, like it shouldn't be hard to tell, but for some reason I find it a little hard to tell. I don't really know why. Or 240 degrees. That's my least favorite angle. We get there by doing this. And this one is 11 pi over 6, or 330 degrees. Went with all threes there accidentally. Like that. This will be 5 pi over 4, or what is that? 225 degrees. And we get there by doing this. So it's always counterclockwise. Got to know that you're going counterclockwise. And then 5 pi over 6, or 150 degrees. And we get there by going like this. All right. So we got them all labeled. And we know degrees. We know radians. Good for us. Now, what I want to do is I want to look at these. And I want to say, all right, if I made a right triangle out of these by going from the terminal side to the closest part of the x-axis. Okay, so we're going to do that. Terminal side to the closest part of the x-axis. So I'm going to change up here. So I would do basically that, and then I have a right angle. Now the question we want to answer is, what angle is this? So think it through, right? So if we had gone all the way around, we would have gotten to 360. We didn't go all the way around. We only went to 300. So what's the difference between 360 and 300? This is 60 degrees, or pi over 3. So this 5 pi over 3 is called a pi over 3 angle. And that's the reference angle. So our reference angle here is 60 degrees if you're in degrees, or pi over 3. It's almost easier to think of reference angles in, well, it depends, right? So like if I say 7 pi over 6, I'm like, what do you think the reference angle is? It's like, it's over 6, so it's probably pi over 6. In degrees, it's maybe a little easier to calculate them. I don't know, it really depends. Let's make our triangle. So we always go to the closest part of the x-axis. And then we're always interested in the angle that's at the origin. So this angle right here. And then this, so think of it, you went 180 degrees to get to the horizontal, and then you went 30 degrees more. So this is 30. I basically got that by doing 210 minus 80. 210 minus 180, or pi over 6. And it is a pi over 6, 7 pi over 6, pi over 6 reference angle, kind of makes sense. Let's see. So if you're going to try to use that idea, you have to be in simplest reduced form. If you're not in simplest reduced form, problem. So here, okay. And then the angle we're interested in is here. So notice the way I'm drawing the angles. I'm always trying to draw them so they're counterclockwise, so that you get a positive angle when you think about it. It's like a small subtle thing, but I think it's important. Here again, we would have gone to 360, but we stopped short by 45, right? 360 minus 315. So this is 45 degrees, but our radian measure would just be pi over 4. The denominator is over 4. Makes sense. Let's keep going. So so far we've got one of each. It turns out that you'll get one of each in each quadrant, which kind of makes sense if you think it through. So here and this, and then if we kept going, you can see you should have gone all the way to 180, but you stopped short. You only went to 135. 180 minus 135 is 45, or pi over 4. And then here, so one key is you always need to go to the closest part of the x-axis, and then the angle is always the one that's at the origin. Those are the two things you need to remember. Closest part of the x-axis, never the y-axis. We don't even need the y-axis, really. Closest part of the x-axis, and then angle at the origin. So this one is 60 degrees short, which would be pi over 3, and it's a pi over 3 angle, so that feels right. Here, oh, this is going to be another pi over 3. Closest part, right angle. Angle we want is here. We went too far in some sense in this case. We went 60 degrees too far, or pi over 3. So our reference angle is always the angle formed between the terminal side and the closest part of the x-axis. And the y-axis basically just doesn't exist for the purposes of doing this. Like, we just don't care. Like, what angle does it form with the y-axis? No one will ever ask you that. Well, I mean, you might be asked that, but like, there's not really a compelling mathematical reason to be asked that. This one, we are 30 degrees short. So this is a pi over 6 reference angle, or 30 degrees. I mean, it depends. Are you in degrees or are you in radians? Here we go. There. So we went too far in some sense by 45 degrees. 225 minus 180, or pi over 4. So reference angles in radians, I think, are probably definitely easier to find. I know that I'm going back and forth on that issue. I don't really know which one I believe. In the first quadrant, the reason there's no first quadrant angles here is because in the first quadrant, the angle and the reference angle would be the same, right? The closest part of the x-axis is the positive x-axis. That's the angle that you rotated. Like, there's nothing exciting there. That's why you're not really being asked about those. But you need to know that in the first quadrant, the reference angle and the angle are actually going to be exactly the same. So what's good about this in a lot of ways is, like, the words here, feel free to read them. I'm going to not. What this is sort of saying is that the absolute value of the trig function, oh my God, that's supposed to be a G. The trig function of an angle is equal to the trig function, of the reference angle. That is always true. So why do reference angles always have a positive value for their trig functions? They always have a positive value because a reference angle, this, I've provided exactly 0 space for you to write these things. So let me see here. Where could I put this? Where is there space? Nowhere. Okay, so here we go. Reference angle. So a reference angle is always an element of quadrant 1. Therefore, all trig functions, I don't know if you noticed, I put the dot for I before I wrote the I. That's weird. All the trig functions are positive. Therefore, the absolute value of the trig functions of the angle is always going to be equal to the trig function of the reference angle. This is really important. It means that we can kind of like focus on the first quadrant and deal with that, and then just decide like what quadrant does the angle fall in, and then based on ASTC, will things be positive, will they be negative? Anyway, we're done with this page. Nothing super challenging on this page, I would say. Reference angle always one of these. So actually, I'm a fan of this picture, which again, who spaced this out? Your only possible reference angles will be, you've got to draw one of these triangles. So let me see if I can do it. there, and then I want to go, oh boy, like there, and then I want to go, oh, that's not horizontal at all. So what I'm trying to do, I think of it as a butterfly. Some people call it a bow tie, which is, that's equally good. There, and then there. You draw yourself the bow tie, right? And then this is entirely wrong, so don't do this. I got like lost in trying to do it. Here we go. All right, I got an idea. I'm gonna draw a square, if this will let me, which I hope it does. Turn into a square. Do it. That didn't turn into a square at all. Here we go. One more try. Yes. Okay. So the reason I'm trying to do this is now the diagonals of this are going to be useful to me. So here, yes, this is going to work. Here, I'm about to erase something, so don't worry. Okay, now erase the square. Boom, perfect. The bow tie, the butterfly, whatever you want to call it. This is your picture, and your reference angles are here, are here, are here, and are here. There you go. So you will never draw a triangle that doesn't look like one of those four. If you draw a triangle that doesn't look like one of those four, you're definitely wrong. Just like how my first picture was 100% wrong. So this is the picture that we'll end up using. And a lot of takeaways, but not too much work. So I'm going to end this here. I will come back in the next video, and we will keep going. So see you there.